In the previous video, we discussed Boyle's law, which mathematically describes the relationship between volume and pressure as inversely proportional. We would write that as pressure is inversely proportional to volume. However, the remaining gas laws are all directly proportional. This means that we can use linear equations, think y equals mx, to describe the behavior of the remaining variables in gas experiments. In this video, we will cover Charles's law, the definition of Kelvin, and Avogadro's law. In 1787, a scientist named Jacques Charles quantified something that made perfect sense. When you heat up a gas at constant pressure, that gas will expand. When Charles plotted the volume versus temperature data he collected, he found that he could describe this relationship as directly proportional. As a mathematical expression, that looks like volume is equal to some kind of slope, which we'll use K for constant, times the temperature. Just like with Boyle's law, we can use the idea that a particular sample of gas will keep the same constant K and derive a useful equation for predicting the volume and temperature at different times. Consider an equation where we had V1 equals K times T1. If you divide both sides by temperature, you would get volume 1 over temperature 1 equals K. This would also hold true for a second volume and temperature. And since the K, the slope, stays the same the whole time, you could set these two equal to each other. This final expression is often called Charles's law. While studying this ideal gas relationship, Charles stumbled upon something rather curious. Every time he extrapolated his data to a volume of 0, the best fit line would hit a temperature on the axis right around negative 273.15 degrees Celsius. In 1848, a scientist named William Thomson, who was later given the title Lord Kelvin, realized the importance of this phenomenon. Since obtaining a volume of less than 0 is impossible, it follows that a temperature of these gases cannot go below negative 273.15 degrees Celsius. This temperature became a basis of a new temperature scale, named after Lord Kelvin, where 0 Kelvin is defined as absolute zero. All of your gas law calculations should be done in Kelvin units. To convert Celsius into Kelvin, all you need to do is take that Celsius unit and add 273.15, though some textbooks don't use the 0.15. The second gas law that we will consider in this video also makes sense with common experiences. For example, consider blowing air into a balloon. If you push more moles of air into the balloon inflates. This relationship also turns out to be a direct relationship called Avogadro's law. Sometimes this is represented as the volume is directly proportional to the moles. In the gases unit, we're going to use N as our number of moles. We can use the same mathematical reasoning to derive a useful equation for predicting volumes and mole amounts at constant pressure and temperature. Consider V1 equals Kn1. You could divide both sides by N and then get V1 over N1 equals K. This would also hold true for a second volume and mole amount, provided that these are both existing at the same pressure and temperature. Then you can substitute and get a useful expression, V1 over N1 equals V2 over N2. This is just another form of Avogadro's law. Calculations involving these equations should always be completed using Kelvin units. Make sure to practice plenty of examples to help you memorize the formulas.